have what we call a difference of squares. All right. And when we do it in grade 11 and 12, again, we are not just doing it with variables. We're doing it with trigonometric functions such as sine, cos. Okay. We do it with logarithmic functions. We do it with exponential functions. We have to do all this factoring with all these other functions, and we apply them to it. But the process all starts today. And one of the things is this and this. X squared plus 25. X squared plus 25 is not something you can factor. Okay? The reason being is you can't multiply something by itself and get just x squared plus 25. You would have a middle term somewhere along the way. So this isn't something that can be done. However, x squared minus 25 is a different story. This is called difference of squares. Difference means subtract. Squares means I have perfect squares. Now, this does not have to be done with just perfect squares. However, you are only going to do it with perfect squares. Okay? And what I mean is this. Is the first term a perfect square? Yeah. Can you square root it and come out with something that I can multiply together? Yeah. How about the second term? Yeah. If I square root 25, what do I get? 5. All right. There are two ways to look at this. The first way is to understand simply this. If it is a perfect square, subtract a perfect square, it will factor to the exact same thing every single time. That's the one way. Whoops. Getting all excited here. That's one way to look at it. The second way to look at it is to look at it like this. Put two sets of brackets. Exactly what you've done so far, right? What are the factors of x squared? X. X and x. That goes there. And what is the square root of 25? 5. So 5 goes here and 5 goes here. So it's the same every time. And this is the catch to it. One bracket is a plus and one bracket is a subtract. Difference is squares. X plus 5, x subtract 5. A squared subtract b squared. A subtract b, a plus b. That's the one I'm going to refer back to all the time. When I use difference of squares, I'm going to say a squared subtract b squared is a subtract b, a plus b. It works all the time. So let's reverse the order of this and let's see why it works that way. So what I want you to do right now is I want you to FOIL that. Okay, so let's FOIL this. X times x is x squared. Outside, x times negative 5, 5x. Negative 5x. Inside, 5 times x plus 5x plus 5 subtract 5.
No. Take away 25. Oh, sorry.
Take away 25. Subtract 25. Now, when you look at the middle terms, what do you notice? They cancel each other out. Well done. So this is why I end up with x squared minus 25. This is called difference of squares. This is a special case of factoring. In order to do that, we are going to have a perfect square subtract a perfect square. You cannot have a perfect square add a perfect square. That does not work. You can't factor that. Has to be a subtract sign in the middle. Hence the word difference. We okay so far? Yeah. Okay. Now, the next thing that we're going to get into is what we call a perfect square trinomial. So I'm going to start by going x squared Okay, and there will be two things that we can figure out. Again, how to get there and why it is that. So, first things first. Same. Two sets of brackets. Okay. Factors of x squared. X and x. What are the factors of 16 that add to give me 8? 4 and 4.
Or 8. Oh, wait, no, it'd be 8.
Plus 4 and plus 4. What do you notice about the two brackets? They're the same. A perfect squared trinomial will result in the binomial being squared. So x plus 4 squared takes you to a binomial.
What happens if the last number doesn't have a square root?
This doesn't work. No, it's a perfect squared trinomial.
Oh,
It works this way. Now, here is a little hint to figure it out quickly whether this is a perfect square trinomial or not. Okay? And that is, if you take, let me make sure I got this right in my head. The square root of the first term. So the square root of that term. So I'm just going to write this out. Times the square root of the third term. Times 2. That will equal my second term. All right. Square root of x squared is what?
X.
X. Square root of the third term is
16.
square root of it.
Oh, 4.
4. And I times by 2. X times 4 times 2. 4 times 2 is? 8 times x is? 8x. That will give you that every time. So if you want to check quickly whether or not it's a perfect squared trinomial, square root the first term, square root the last term, and times by 2. If it equals your middle term, you know that it's a perfect squared trinomial. Which means then that you would end up with a binomial times itself, or x plus 4 with a squared value. Yes, Jackson?
On the 1 and the 3, what is that on top of it?
First and third. Yep. Okay. That's it. That's what we're looking at today. So you're still doing your factoring, except you're going to come across perfect squared trinomials when you factor them, and you're going to come across difference of squares. So if you're looking at the difference of squares one, take a look at question 5 quickly on page 99. A squared a perfect square? Yeah. How about 100?
Yeah.
Yeah. So what does that factor, and is it a subtract? There's the next question. Yes. So what does that factor to?
A minus 10.
Yeah, which is what?
A minus 10.
Nope. Ailey, louder. A minus 10, A plus 10. How about t squared subtract 49? What does that factor to?
T plus 7, T minus 7.
Yep, that's it. You're nailing it. X squared plus 4.
Not possible.
Not possible. 64 subtract h squared.
8 plus H, 8 minus H.
8 plus h, 8 minus h. Yep. We see what's at, like, see how that is? Pretty simple. As long as you can tell that it's a perfect square, subtract a perfect square, it's the same every time. All right? How we doing? Think we can do this? Okay. Any questions from 5.3? Did you at least finish to the end of page 95?
Yeah.
Yeah? Okay, we're golden then. Let's go to page 99. And let's work until we get to probably about, I don't know, question 10 or 11. Okay? Any issues today before I shut the YouTube off?
What about for like E, if they both are square, is that really different?
Or E?
Yeah. Or 5, like on sports, on 5.4.
What page are you on? Dryden?
99.
99.
Like the ones we just went over.
Yeah, question what?
E5.
E?
Yeah.
What's the first thing you do in factoring?
Square.
No. What's the first thing you do in factoring? Greatest common factor. So you start there, and then it might give you a perfect square, subtract a perfect square. Okay? All right. We good? Okay.
And we can skip one at the top, just up to the title, right?
Right.